So it's kind of hard to follow a talk like that because it's kind of a downer. But we'll try to talk about something maybe a little more upbeat that is also hopefully interesting. So release engineering and rugged DevOps, is there an intersection? By the way, my name's Paul Reed. So if you were here last year, you might say to yourself, wait, this looks a little familiar. And yes, I did do a presentation with actually the same name. And the question was really like, how does release engineering and rugged DevOps or security, how do they intersect? By the way, show of hands, are there any release engineers in the room? Okay, half a hand went up. Oh, there we go. Awesome. And then how many security people do we have in the room? Perfect. All right. I think you're going to like this. All right. So anyway, this is what we found out over the past year about whether or not there's an intersection between rugged DevOps and release engineering. So this is the 2.0 version of this presentation, as you can see. So this is me. I'm not going to go through this whole slide. There's only like 2 bits of important information, which is my Twitter name, so you can feel free to tweet things at me. If I said something that is confusing, I'm happy to have Twitter conversations about it. And then my background is build and release engineering. I was a build and release engineer for, I still am in many ways, for the last 15 years. All right. So I want to do a really quick kind of review from last year about the questions that we looked at about how rugged DevOps and release engineering, how do they intersect? So when we looked at it last year, we kind of went through a number of things, similarities. So we both look a little off to developers in the business, right? This character in the Phoenix project that runs around with a black binder to all the meetings, right? Release engineers do that as well. If you read the Phoenix project, kind of security and release engineering are both full of a bunch of quirky characters, a lot of like, what would you say you do here type folks. And so we share that. We both can often be found shoveling DevOps unicorn poop. I'm actually surprised that this picture hasn't been in a presentation yet this morning. But we both feel this way. This is Pete Cheslott came up with this. Release engineers often feel this way about DevOps as well. It's like, oh, we're doing the DevOps now, and we have to deal with this. So we share that. Including our work in project plans and scoping and requirements, we're not as an industry very good at that. We're not good at that with security, and we're not particularly good at with release engineering work that needs to be done. We kind of just assume it's going to happen, or we do it in our free times between releases, or we tack it on to the end. So we share that as well. But when whatever that is, if it's security or build machines break or something like that, then we've got a lot of eyes on us, and they all want us to fix it like immediately. As we've heard before, we both have a reputation for no, well-established reputations for no. Can I create a branch? No, you can't. Can I do this? No, you can't. The nature of our roles is undergoing a fundamental shift, right? So we are seeing a big movement in the industry from people doing the thing, release engineers releasing software, security people kind of doing security, a shift to building platforms within the context of an organization to do that thing so that other people can do at least part of the things that we all used to do. So that's a huge shift for both of us in the way that we go about our jobs. And probably most importantly, the industry is, I think, really starting to get it. And to the point of Josh's presentation that we saw, there's some really good evidence that this is starting to make sense to the industry, that we really need to care about these things. Same thing on the release engineering side. So that's really good. Then the question is, well, okay, how does release engineering impact relate to converge with security? And these, again, were all kind of questions that I posed last year. Software supply chain. So there's been a lot of discussion of software supply chain. There's actually a really great story that Josh tells about a bank that had a Java library, and they had something like 60 different versions of this particular library, and something like 58 of them were vulnerable to a particular problem. Now, one vulnerable library, one version in your product is a security problem, but multiple versions of a vulnerable library, that's a release engineering problem. So that's one of the really interesting core overlaps between the work that we do from a software supply chain perspective. We talked a little bit about old-fashioned software delivery mechanisms. I actually told a story that last year I went to download the Office 365, or Office, not 365, the version you actually download, and Microsoft still wanted to send it to me over an HTTP link, which if you're downloading it at hotel Wi-Fi or something like that, may give you pause if you care about those things. So how we deliver, the delivery mechanism for our software has a very interesting overlap with security. Artifact management is a big deal. You can't really have software supply chain unless you have good artifact management. That's still something certainly release engineers do, but it's still something we struggle with. The bold new world of containers. We're actually going to talk a little bit about containers today, actually. And then every versioning bike shed ever. And there's an example that'll pop up again from last year, just because it's kind of a funny example. But so these were the things that I posed as a question to this community of security practitioners about how release engineers sort of overlap with the work that you all do, and how we might be able to help help each other do our work better. So what did we find out last year after I sort of posed these questions? We're going to take a look at some of the updates in these areas and some of the tools to help that we found will be helpful, I think, in terms of what we can do this year. So what we learned was the ways in which we consume software continue to be problematic. The ways in which we produce software continue to be problematic. And then finally, in many cases, we're ignoring heuristics that can help us. So we're going to talk about what those mean, what that means. All right. Problematic software consumption. So there's a lot of data to support the claim that we are stitching together software from more places than ever. We are seeing, it used to be that you would just upload, your source code to SourceForge or maybe to Nexus, and that would be the end of it. What is surprising to me is how many products I see these days that are actually a little sprinkling of Node and a little sprinkling of some Ruby in there, and maybe there's a Java component or a native component, right? So this discussion of leveraging open source software, it's not just that we're using open source software and we're using more of it. We're using heterogeneous open source software. We're using it in different languages, and developers are kind of going hog wild on picking, whatever language is best for them, which is a great thing, but it causes some interesting problems for us. What this means is that your software supply chain may have more actors involved than you think. Now, who remembers the NPM gate or left pad gate problem? Okay, this was where a developer, a Java developer, JavaScript developer, removed a package from the NPM registry, and that broke basically the world. And because a bunch of particular projects relied on this particular library, and it kind of broke the internet for a little while because people then went to try to do deployments that involved the NPM process, and they literally could not deploy. Now, I don't mean to single out the Node community or NPM, because it turns out that RubyGems has had the same problem. GitHub has gone down a couple of times in high-profile incidents. And so people find we're relying on all of this sort of external infrastructure, and when it goes down, then we may not be able to actually build or do our deployments. Now, what's interesting about this is that means that when we rely on those people are involved in our software supply chain process. And they may make different trade-offs or have different engineering aesthetics about the way that they manage source code than we as an organization might, or that we as security researchers might, or that we as release engineers might. Another consequence of this is knowing exactly what you're getting can be difficult. This is a slide that I did have from last year about OpenSSL and version numbers. What's interesting about OpenSSL and version numbers, and I talked a little bit about the version number bike shed, but it's this idea that continuous delivery has started to sort of de-emphasize the idea that version numbers are important. People always say, well, I don't care what version of Facebook I'm running, right? Is kind of the running joke. So why this is problematic is you're getting into situations now where some open source projects don't even really do version numbers anymore. Like they just expect you to pull the code off of GitHub, and trunk is tested with some CI tool, and if it's green, you're supposed to be able to pull any version you want, right? What this misses is that version numbers are a human factors issue. It's how we all communicate with each other about what we're actually running. And so this is sort of problematic, I think, in production. Making sense of what you have can be difficult. So this is a Git graph on the right there of some source code. Has anyone ever run into a situation where you're kind of investigating a security problem, and what you find is somebody forked some code on GitHub, and then they had to make some changes, some local patches to it, and then question marks, right? They just have a fork that's lying out there forever, and they may have to go update it, or maybe it never gets updated. Has anyone ever run into that when doing forensics? Yeah, I see some hands going up. So part of the problem with this is, obviously, Git makes the forking part really easy. GitHub makes the forking part really easy, but it makes the management of that source code really hard. And now that code could be in your product, and you have to deal with it. So the point here is, even if you have a software supply chain, you need to actively manage it to be sure that someone else doesn't actually own it. Now, the good news, as an aside, this is one of the tools I wanted to talk about, and it's a tool that I wrote. The good news is this has been a solved problem for about 20 years. CVS had this thing. Now, your opinions on CVS aside, had a concept of vendor branches. And so there's actually a tool that brings that concept to Git and GitHub. And what's interesting about this is that basically, I'm going to just put these all up here. It gives you kind of this old idea of vendor branches, but in the new GitHub model. So it creates a copy of artifacts, so they're under your control. You're not relying on pointers to other things. It supports a standardized version format. You can do custom patching to your heart's content, and it helps you manage that stuff. And it also helps or supports developers working on standard GitHub forks. So the point here is it isolates the daily machinations of GitHub projects from your ability to ship software, but it also helps you manage the changes that your developers may be making locally better to source code that you all are required to have some involvement with from a security perspective. So in other words, it changes that picture I showed you before. It changes this, and now that same thing looks like this. It's much easier to sort of understand what's going on. You'll see a bunch of commit messages about custom patches that were reapplied. And it also makes this process easy, right? It automatically records information that you care about. So you see the commit message contains a bunch of information so that you can go do it. Now, if you've ever used GitHub or used GitHub forks, this may seem a little bit odd or weird, but the difference is it's optimizing for the organization and its needs with regard to supply chain. It's not optimizing for a developer being able to quickly and easily click a button on GitHub, make a bunch of changes, and then put that code in your product. Now, it supports that, but the focus is a little different. So if you're, the point is we can do both. We can optimize for developers, and we can optimize for software supply chain. So the other sort of problem that we ran into is problematic software production. So what I mean by this is the way we produce software or the way we create software within our organizations. So who's had this experience? Who is responsible? Who's had to support Docker in the organization? Okay, I see some hands going up. So.
Stand in front of that guy.
Lady out of there.
Here comes the Docker. So when supporting Docker in your org, did anyone else kind of have that experience? Like, here comes Docker, get out of the way. I felt like that old lady there, where she's like trying to get out of the way of the Docker. We're going to talk about Docker, and I was giving John, because he works at Docker, a hard time. Trust me, there's a punchline that will make you happy. It's not all Docker is horrible. So this is I think the problem that a lot of us had when Docker came into the ecosystem. It's like, okay, here comes Docker. We just have to support it, and this is what's going on. So there's this question, though, what's in a container anyway? And sometimes the answer can be, and this was the case early on in the Docker ecosystem, and oftentimes it still is the case. You don't know. You just kind of don't know. Now, you might say, yeah, this was true a year ago or 2 years ago, but I wanted to present some data that Gareth Rushgrove, he does the DevOps Weekly newsletter, if you're familiar with it. He presented this last month, I believe, or a couple weeks ago at Config Management Camp. And he says he found out that the majority of people using Docker are using images containing an entire operating file system. So this question about like what's in a container, it turns out the kitchen sink is in the container, right? Everything is in the container. And this is problematic. As Julian Dunn pointed out, Julian Dunn tweeted this, he's a friend of mine. And it's kind of funny because he was saying, one of his concerns is that Docker is the new war file, right? People just kind of take the war file, unzip it, throw a bunch of stuff in there that you have no auditability about, and then zip it back up and send it down the line, right? And his concern was Docker containers are going to be that have that same problem. Now, here's another problem with Docker that people have run into. Vine's source code, the entire source code was leaked via Docker images. And there's a story about this. This happened in March of 2016. But I want to make a point here. This article says it's important to understand that this walk in through the front door hack was not an exploit of vulnerabilities in Docker itself or in Docker images. So you might look at this and say, oh, geez, what's wrong with Docker? And the issue is that it's a new technology, and it was enthusiastically adopted by the developers, and they may not know all the implications from both a release engineering perspective, but also from a security perspective about the choices of those decisions. And so Docker adoption is kind of a good case study in what is going to happen when there's another tool that really takes our industry by storm. Right? It's not a Docker problem. It's not that Docker's insecure. It's that we were so exuberant to use it that we didn't really look at all of the issues that we might want to look at when we're deploying it in our organization. Who here has heard of continuous delivery? Hopefully everyone's hand goes up. So we're all building continuous delivery pipelines. We have more continuous integration and continuous delivery tools than ever. These are a few of them. What does this actually mean, though? It means we have more attack surface than ever, right? So there's a number of stories, right? As we tie all of these tools together to do, full from commit out to production, well, that means that if I can somehow get those access keys that our continuous delivery pipelines have, I hold the keys to the kingdom. And there's a number of stories where security teams internal have gotten control of that continuous delivery pipeline and been able to do not so great things with them. As another example, when we talk about sort of release engineering infrastructure, I actually worked with a company once that you could literally go to any network jack in the building, plug your laptop in, launch the version control client in its default setting, and they didn't password protect anything. So you could just download their entire source code and walk out of the building, right? So this sort of infrastructure is actually sort of a security problem as well. Yeah. So this is an interesting quote. We're all applying speed and scale to our CE pipelines, and they may need to have a little more security and a little less speed and scale. That was a security researcher that said that. So missed heuristics. These are just weak signals sort of in a release engineering context that from a security perspective should show you that maybe something's a little amiss. So build processes taking a long time. The question is, what is it actually doing? And a lot of times what it's actually doing is it's cloning some external repo from somewhere, or it's doing some NPM process that's pulling in code at build time so that you can't really audit it because it might change whatever's on the remote end. So that's a problem. One of the ones I like to say is build processes that you can't do a train. That means, disconnected and build your code on a commuter train or something. This means your build process isn't isolated, which also probably means it's not reproducible because you're relying on something external to get that build process to work. Build artifacts you shipped but can't find later, so that means you can't do forensics on your build artifacts, right? It's funny, the artifact we often talk about is like debug symbols and things like that. But really, for security purposes, like if you have to go look at how a bit of code or a particular issue came up in a piece of software, but your artifacts get rotated out because you don't have good hygiene around them, then that's a problem as well. There's a quote that I'll read from my computer science undergrad professor that kind of came to mind here. Think of it as house cleaning software bugs are like cockroaches. They hide in the darkest, messiest parts of your code. To get rid of cockroaches, you wouldn't hunt them down one by one. Instead, you'd clean up the house and get rid of their hiding places. Do the same in your code. And I would argue we need to do the same in our continuous delivery pipelines as well, and our build processes. So, what should we look forward to this year? This is sort of the, if you're thinking about, and I'm actually really glad that we're mostly security folks in here and not release engineers, because I think this advice will be particularly actionable for you. Introduce your release and security engineers. So if you don't know who's responsible for building your continuous delivery pipelines in your organization, whoever that is, you should go find them and introduce yourselves. As I said last year, we worry about the same things. And so if you don't know those people, you should say hi to them. They probably are interested in the work that you do as well. You should task the two groups to research your software supply chain. I guarantee you will find something weird and odd and interesting when you go and do that. And the release engineers, I think, are really good at dissecting build processes and figuring that part out. But they don't, I can tell you as one, and as one who works with a bunch of release engineers, this goes for operations engineers as well. We need your help as security professionals, because we can give you the information, but we don't always have the context that you have around what the security implications of that information actually is. Start a project that engages the other teams with these practices. So I'll give you an example of this. It's one that I like to do. If you have a continuous delivery pipeline, we like to set up a mirror, a parallel one, that has warnings, compiler warnings cranked all the way up, and then error on warning. And usually that build doesn't get very far if your build process has a lot of build warnings. But what we find is developers will start to fix these warnings when they are bored and have nothing else to do. And it sort of becomes kind of gamified. But the other interesting part that we found out, and I've done this exercise 3 times, about half the warnings that get fixed are software bugs. And about half of those are actually security related or security critical bugs. They're running off the end of arrays or doing things like that. So that's one of those things where, from a release engineering perspective, you can get your security teams, then go engage with the developers. That's really good. So last year I asked you, how do they intersect? And this year and the year coming forward, I'd like to ask you, how can we engage and help each other more? Because I think we've demonstrated there actually is a lot of overlap between release engineering and security. So let's go ahead and find that out. Now, I want to leave you with one last reminder before lunch. To the question, who owns your software supply chain? I want you to remember the answer is you do. And if you need a handy-dandy reminder, you can go to whoownsmysoftwaresupplychain.com, and it will let you know who does. That's all I got. Let's go have lunch.